So what is the formula for finding the key row? Key row is equal to, first you have to convert the inequalities into equalities by adding slack variables. So now you can cross verify this whether this value satisfied the optimality or not. Now we can find Zj value. Zj value is Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my last session, I have discussed about Simplex method. LPP can be solved by using Simplex method also. So what is the first step to solve the Simplex method? First, you have to convert the inequalities into equalities by adding slack variables. So in Simplex method, we are adding the slack variables for converting the inequality into equality. That means for converting into standard equation, we are adding the slack variables in Simplex method. So today I will continue that Simplex method. Let's get started now. I will discuss the Simplex method. We have some different equalities and inequalities in Simplex method. So today I will discuss the unbounded solution. So what is the meaning of this unbounded solution? Already we have studied this unbounded solution in graphical method. So what is the possibilities you will get it in unbounded solution? Let us understand with an example. So we have objective function and subject to constraint. So what is the first step? First you have to convert this inequalities into equality. That means we have to convert this in standard form. I'll write the objective function max is equal to 2x1, 3x2 plus 4x3. We have three decision variables x1, x2 and x3. First constraint is minus x1 minus 5x2 minus 9x3 less than or equal to 2. Less than or equal to 2 means I am adding the slack variable s1 is equal to solution is 2. And the second constraint is 3x1 minus x2 plus x3 less than or equal to 10. So I am adding the second slack variable s2 is equal to 10. And the third constraint is 2x1 plus 3x2 minus 7x3 less than or equal to 0. So I am adding the slack variable s3 is equal to 0. Now this is in a form of equation. Now we can find the initial simplex table. Initial simplex table. So what is the first step? First you have to write the objective function's coefficient. So Cj stands for coefficient of objective function. So after this inequality into equality, I'll write the objective function 0s1, 0s2 and 0s3 because I have three slack variables here. So now we can find the initial simplex table. So first find the basic variable. We have x1, x2, x3, s1, s2, s3. x1, x2, x3, s1, s2 and s3. And we have to find the solution and ratio. So next you have to write the coefficient of objective functions. What is the coefficient of this x1? We have 2. Coefficient of x2 is 3. Coefficient of x3 is 4. Coefficient of s1 is 0. s2 is 0. s3 is also 0. So this is the first step, and here I am taking the three slack variables s1, s2 and s3. And what is the coefficient of this slack variables? 0, 0 and 0. So here in this position you have to write the coefficient of x1, x2, x3, s1, s2, s3 in equation number 1, equation number 2 and equation number 3. In equation number 1, we have the coefficient of x1, it is minus 1, minus 5, minus 9 and coefficient of s1 is 1, s2 is not there, s3 is not there and the solution is 2. And next equation number 2, coefficient of x1 is 3, minus 1, 1, S1 is not there, S2 is there, S3 is not there. Solution is equal to 10. And the equation number 3, x1 coefficient is 2, x2 is 3, minus 7, S1 is not there, S2 is not there, S3 is 1 and solution is equal to 0. So what is the next step? So next step is you have to find Zj value. How to find the Zj value? 0 into -1 plus 0 into 3 plus 0 into 2. Already I have discussed this in my previous session. All the Zj value is always 0 in initial simplex table, only in simplex method. So value is 0, 0, 0, 0, 0, 0. 0 into any number is always 0 only. Then you have to find Cj minus Zj. After finding this Zj, you can find Cj minus Zj. So 2 minus 0 is 2. 3 minus 0, 3. 4 minus 0 and 0 minus 0, 0 minus 0, 0 minus 0. Now you can check whether these values are satisfied optimality condition or not. So already I have told you that for maximization problem, all Cj minus Zj value should be less than or equal to 0. That means negative or 0. All the values should be less than or equal to 0 when it is in the maximization problem. If it is minimization, all Cj minus Zj should be greater than or equal to 0. That means positive or 0. So here you can cross check this. All the values are positive only. This is maximization problem. All Cj minus Zj should be less than or equal to 0. That means all the values should be negative. But here we have positive values. So we can tell it is not satisfied optimality condition. Not satisfied optimality condition. It is not satisfying the optimality condition. So you can move further. Here you can check the maximum value. Maximum value is 4. So this 4 comes under the column. It is x3. This column is called as key column. The maximum value is 4. This comes under x3 column. This column is called as key column. So now I will mark this. It is a key column. After finding the key column, we can find the ratio. So what is the formula for finding the ratio? Solution divided by key column. So solution by key column. So 2 by minus 9 is equal to minus 2 by 9. And 10 by 1. 10 by 1 is equal to 10. And 0 by minus 7, it is 0. So you can check the key row in array. So now you can find out the key row. So already we have the key column. Key column is x3. Now we can find the key row. So how to find the key row? You just check the ratios. Here I have negative and here I have 0. Here I have negative symbol and I have 0. For finding the key row, you are not supposed to select the negative value or 0 or infinity value. You have to select only the least positive value. We have only one positive value. So I will select this 10 is my key row. This comes under S2. So this is my key row. Key row is S2. So S2 is living variable and x3 is entering variable. Entering variable is x3 and living variable is S2. S2 means it is a key row. Key row is called as living variable and x3 is key column. Key column is called as entering variable. Now you can find the key element. So here we have three numbers -1, 1 and -7. So here key element means the number which is common for both key row and key column, that is 1. So 1 is my key element. Key element is equal to 1. So S2 is living variable, x3 is entering variable and key element is 1. Now we can move further for finding the iteration 1. So this is not satisfied the optimality condition. So we can move further. Here we have to find the iteration 1. Again same thing, have to fill the table. Here you have to find the coefficient of objective function, that is 2, 3, 4 and 0, 0, 0. So what is the basic variables? x1, x2, x3 and s1, s2, s3. We have to find the solution and ratio. So here basic variables we have s1, s2, s3. I am deleting this s2 variable because it is an outgoing variable s2. In place of s2, I will add this entering variable called x3. So coefficient of x3 is 4. So here 0 s1, 4 x3 and 0 s3. 0 s1, 4 x3. I am adding the entering variable x3. So coefficient of x3 is 4 and again 0 s3. So now using old values and key element, we can find the new values. So here key element is 1 and first list all the key rows and find the new value. So which are the key rows? 3, minus 1, 1, 0, 1, 0, 10. 3, minus 1 key row and non-key row. Key rows are 3, minus 1 and 1, 0, 1, 0, 10. 1, 0, 1, 0, 10. So key element is 1. Key element is equal to 1. Using key element and old value, you can find the new value. So what is the formula for finding the key row? Key row is equal to old value divided by key element. So 3 by 1 is 3. Old value by key element is 1. Old value by key element 0 by 1 it is 0, 1 by 1 it is 1, 0 by 1 0, 10 by 1 it is 1 and next 10 by 1 is equal to 10. Now you can find the new value in place of x3. It's 3 minus 1, 1, 0, 1, 0 and 10. Here I got the new value and I have two more rows. This is non-key row and this is also non-key rows. Here using this non-key rows we can find the new value. List all the non-key rows. Minus 1, minus 5, minus 9, 1, 0, 0, 2. Minus 1, minus 5, minus 9, 1, 0, 0 and this 10. 1, 0, 0, 2. Using this non-key rows, we can find the new value. What is the formula for finding the non-key rows? Old value minus corresponding key column into corresponding key row divided by key element. Using this formula, you can find the new value. Now, we can find the new value using this non-key row. First value is minus 1. Corresponding key column is minus 9 and corresponding key row is 3. I'll repeat. Minus 1 is my old value. Corresponding key column is minus 9. Minus 9 is common to all the non-key rows and corresponding key row is 3. Minus 1 minus 9 into 3 divided by 1. Minus 1 minus 9 into 3 by 1. Minus 1 plus 27. So it is 26. I'll write 26 here. And second non-key row is minus y into minus 9 into minus 1 by 1. So corresponding key column is minus 9 and corresponding key row is minus 1. So minus 5 minus of minus 9 into minus 1 divided by 1. Don't get confused. Use this formula. Minus 5 minus 9 into minus 1 divided by 1. Minus 9 into minus 1 divided by 1. So here minus into minus plus minus 5 minus 9, it is minus 14. Minus 14. And the next value is minus 9. Old value is minus 9. Corresponding key column also minus 9. And corresponding key row is 1. So, minus 9 into 1 by 1. It is minus 9 plus 9 is equal to 0. And old value is 1. Corresponding key column minus 9. Key row is 0. 1 minus minus 9 into 0 by 1. So, answer is 1. And old value is 0. And corresponding key column is minus 9. Key row is 1. Minus 9 into 1 by 1. It is plus 9. And old value is 0. Corresponding key column minus 9. Key row is 0. 0 minus minus 9 into 0 by 1. It is 0. And old value is 2. Corresponding key column is minus 9. Key row is 10. So, 2 minus minus 9 into 10 by 1. So, it is minus into minus plus 9 into 10 is 90. Minus into minus plus. So, 90 plus 2 is 92. So, next last non-key row is S3. So, old value is 2 and corresponding key column is minus 7. Old value is 2, corresponding key column is minus 7 and corresponding row is 3. So, this is key row and this is key column. Old value is 2, corresponding key column is minus 7 and corresponding key row is 3. So, 2 minus of minus 7 into 3 by 1. Old value is 2, corresponding key column is minus 7, key row is 3. So, 2 minus minus 7 into 3 by 3. So, 2 minus into minus plus 21. So, it is 23. 23. So, next value is old value is 3, corresponding key column is minus 7, key row is minus 1. So, 3 minus of minus 7 into minus 1 divided by 1. I will repeat. Old value 3 minus minus 7 into minus 1 divided by 1. So, you will get minus 4. Please calculate this. And old value is minus 7 into corresponding key column also minus 7 into corresponding key row is 1 divided by key element 1. Old value minus 7 minus of minus 7 into 1 divided by 1. You will get 0. And old value is 0. Corresponding key column is 7. Key row is 0. So, you will get 0 again. And old value is 0. Corresponding key column is minus 7 and corresponding key row is 1 divided by 1. So, you will get 7. And old value is 1. Corresponding key column is minus 7. Corresponding key row is 0. So, you will get 1. And old value is 0. Corresponding key column is minus 7 and key row is 10. So, you will get 70. So, these are the new values using non-key rows and key rows. We got the new values. So, now we can find Zj. So, using these two values, we can find the Zj value. So, 0 into any number is 0 only. So, 4 into 3 plus 0 into 0 is 0. So, 4 into 3 is and 4 into minus 1 minus 4. 4 into 1 4 and 4 into 0 0. 4 into 1 is 4 and 4 into 0 is 0 and 4 into 10 is 40. So, now we can find Cj minus Zj. 2 minus 12 is minus 10. 3 minus of minus 4 is plus 7. 4 minus 4 0. 0 minus 0. 0 minus 4 it is minus 4 0. So, now you can cross verify this whether it is satisfied optimality or not. So, here I have 2 negative value and 3 zeros, but I have 1 positive value. So all the values should be negative in maximization, then it satisfies the optimality condition. Again, we can proceed for next iteration. So here maximum value is 7. So this maximum value comes under x3. So x3 is my entering variable. This value comes under x2 column. So x2 is my key column. So x2 is my key column. And you can find the ratio here. So 92, solution is 92 divided by key column is minus 14. So here you will get minus 92 by 14 and 10 by minus 1. 10 by minus 1 is minus 10 and 70 by minus 4. 70 by minus 4 is equal to minus 70 by 4. So if you want to calculate, you can calculate this. So now here I have the key row. So here how to find the key row? We have to choose the least positive value. We don't have any positive value here. So how do you select the key row? If you have any positive value, then we can select the least positive values. But here I have all negative values only. Negative, negative and negative. So we can't move further. This problem is called as unbounded solution, because we are not able to select any least positive value to selecting the key row. We have only the negative values. So we are not able to select the key row in this ratio. So this method is called as unbounded solution. Here leaving row cannot be selected since there is no least positive value in ratio. When all the ratio values are negative, it indicates unbounded solution. So this problem has unbounded solution, no feasible solution to this problem. Moving forward to the next problem. Here I have again 3 variables x1, x2 and x3. First convert this into standard form. Max z is equal to 5x1 minus 6x2 minus 7x3, x1 plus 5x2 minus 3x plus S1, I am adding slack variable for converting the inequalities into equalities, and 5x1 plus S2 is equal to 20, and again x1 plus x2 plus x3 plus S3 is equal to 5. So here I have 3 slack variables, 0s1, 0s2 and 0s3. Now write all the basic variables here, x1, x2, x3, s1, s2 and s3. Solution is and ratio. Now write the coefficient of these objective functions. So 5, minus 6, minus 7, 0, 0 and 0. So basic variables S1, S2 and S3, coefficient is 0, 0, 0. Now write all the coefficient of these variables. In equation number 1 we have 1, 5, minus 3, 1, 0, 0. There is no S2 and S3, it is 0. And in equation number 2, 5, 6, 10, 0, 1, 0. And solution is 15 and 20. And equation number 3, 1, 1, 1, 0, 0, 1. Solution is 5. Now we can find Zj value. Zj value is 0. 0 into any number is 0. And now find Cj minus Zj. 5 minus 0, 5. Minus 6 minus 0, minus 6. Minus 7, 0 minus 0, 0 minus 0 and 0 minus 0. So now you can cross verify this whether this value satisfied the optimality or not. So here I have one positive value. So this value is not satisfying optimality condition. So it is not satisfying optimality condition means you can move further. So you have to find the key column and key row. So here we have to find the key column and key row. So maximum positive value is 5. We have 2 negative values. So maximum positive value is 5. So this comes under the column is x1. So x1 is entering variable in the next iteration. X1 is entering variable. So key column, this is your key column. So key column is X1. And you can find the key row. So solution divided by key column, 15 by 1 is equal to 15 and 20 by 5 is 4 and 5 by 1 is equal to 5. Select the least positive value here. Least positive value is 4. So it comes under S2 row. This is your key row. This is your key row. So entering variable is X1. Entering variable, and deleting variable is S2. It is outgoing variable. Leaving variable is S2. And key element. Key element is common for both key row and key column, that is 5. So key element is equal to 5. So now we can find the iteration 1. So just write the coefficient of objective function. It is 5, minus 6, minus 7, 0, 0 and 0. So basic variables are x1, x2, x3, s1, s2, s3 and solution, and you have to find the ratio. So basic variables. Here the leaving variable is S2. In place of S2, I will write the entering variable called X1. So S1, X1 and X3. So X1 coefficient is 5. S1 is 0, S3 is 0. So now using these old values we can find the new value. Key element is 5. This is key row and this is non-key row and this is also non-key row. List all the key rows now. 5, 6, 10, 0, 1, 0, 20. Key rows are 5, 6, 10, 0, 1, 0, 20. So key element is 5. So how to find the key row? Old value divided by key element is 5. It is 1. And old value is 6. Key element is 5, it is 6 by 5 and old value 10, key element it is 2, 0, 1 by 5, it is 0 and it is 4. So 1, 6 by 5, 2, 0, 1 by 5, 0 and 4. So this is your new values. Using old value, old key row, we can find the new value. Here old value is 1, corresponding key column also 1 and key row is 5. Listen carefully, old value is 1 and corresponding key column also 1 and key row is 5. And old value is 5 and corresponding key column is 1 and key row is 6. So first value is old value 1. Corresponding key column is also 1, key row is 5 divided by key element. So 1 minus, so old value is 1 minus corresponding key column also 1 into key row is 5 divided by key element 5. So 5 get cancelled, 1 minus 1 is equal to 0. So next value is, old value is 5, corresponding key column is 1, key row is 6. So you will get 19 by 5 and old value is minus 3, corresponding key column is 1 and key row is 10 divided by key element is 5. So you will get minus 5. Please calculate this, and old value is 1, corresponding key column also 1 and key row is 0 and divided by key element is 5. So you will get 1. And old value is 0, corresponding key column is 1 and key row is 1 divided by key element 5. So you will get minus 1 by 5. And old value is 0 minus corresponding key column 1 into corresponding key row, it is 0. So you will get 0. And old value is 15, corresponding key column is 1 and key row is 20. So you will get 11. So this is your new values. And we have one more non-key rows here. Old value is 1 and corresponding key column also 1 and key row is 5. Old value 1, corresponding key column also 1 and key row is 5. You will get 0. And old value is 1, corresponding key column is 1 and key row is 6 divided by 5. You will get minus 1 by 5. And old value is 1, corresponding key column 1 and key row is 10 divided by 5. So, you will get minus 1. And old value is 0, corresponding key column 1 and corresponding key row 0. You will get 0. And last 3 values, old value 0, corresponding key column 1 and key row it is 1. So, you will get minus 1 by 5. And old value is 1, corresponding key column 1 and key row is 0 divided by key element 5. So, you will get 1. And last value is 5, corresponding key column 1 and key row is 20 divided by 5. So, you will get 1. So, now you can find this Hj value. 0 into any number is 0, 0 into any number is 0. So, we have one more value. 5 into 1, 5 into 6 by 5 it is 6 and 5 into 2, 10, 5 into 0, 0, 5 into 1 by 5 it is 1, 5 into 0, 0, 5 into 4 is 20. Now, we can find Cj minus Zj. 5 minus 5 is 0, minus 6 is minus 12 and minus 7 minus 10 is minus 17, 0 minus 0, 0 minus 1, 0 minus 0 is 0. So, now we got all the negative values. So, it is satisfying the optimality condition. So, now we can stop the iteration because it is satisfying the optimality condition. For maximization problem, all Cj minus Zj value is always negative only. So, till that we can continue the iterations. Now, we will stop the iteration. So, now max Z is equal to, what is the maximum value here? It is 20. So, x1 is equal to, x1 is 4. So, x2 is not there. Here I have s1 and x3 is also not there. I have s3. So, x1 is 4, x2 is equal to 0, x3 is also 0. Now, we can cross verify the answer. Max Z is equal to 20. Substitute to this objective function. Max Z is equal to 20. 5 into x1 value is 4. 6 into 0. 7 into 0. So, 5 4s are 20. So, 20 equals 20. LHS equals RHS. So, it has feasible solution. So, this is your 3 variables using simplex method. For converting the inequalities into equalities, we are adding the slack variables in simplex method. Keeping in mind, for converting the inequality into equalities, we have to add the slack variables in simplex method. So, this is about your maximization problem. So, in my next session, I will discuss about the minimization problem and different constraints. Thank you.